Welcome to Tuesday, guys. We are about to create our own scatter plot, and we're going to focus today on ones that are in fact linear and what we can do with them once we discover that they are linear scatter plots. So we're going to start by taking a look at all these little sports balls in here, and it tells us that the weights are the X values, and they are written in, oh, interesting, should be ounces. So the weight is in ounces, and the circumference of each one of these balls is in inches. So we're looking at several sports balls that are shown. So our job is to make each one of these values as ordered pairs and then plot them on the coordinate plane. And we're going to see if there's a relationship between the weight of each ball and its circumference. So the first thing I want to do is make ordered pairs for each one of these sets of data. So I'm going to start here. We've got a basketball. It is 21 ounces in weight and 30 inches in circumference. So I'm just going to make myself an ordered pair where 21 is the X value and 30 is the Y value. I'm going to check them off as I go to make sure that I don't write one more than once. All right, this racquetball has a weight of 1.4 ounces and a height, a circumference of 7 inches. The baseball, I miss baseball season right now so much. 5 ounces in weight, 9 inches in circumference. Water polo, this one is 15 ounces in weight and 27 inches in circumference. Then we've got the golf ball. It is 1.6 ounces and has a circumference of 5.3. The softball is 7 ounces in weight and has a circumference of 12 inches. Soccer ball, 16 ounces and 28-inch circumference. Tennis ball, Ziva's favorite, 2 ounces in weight, 8 inches in circumference. And finally, last but not least, our volleyball is 10 ounces in weight and 26 inches in its circumference. So you can think about right now what to expect when we plot all these. Do you think that as the ball gets bigger, it gets heavier? Some of these they don't, right? A golf ball is probably a little heavier than some of these other like light ones. All right, we are going to get ready to plot. So when I am getting ready for this, what I like to do is take a look at my X values because I need to know what my axes are going to be labeled as. So my lowest X value, let's see, it looks like it's about 1.4 is my lowest X value. My highest X value is 21. So I need to be able to get 1.4 to 21 here and space it out evenly. I counted this out and I've got 10 spaces. So if I need to get to a little over 20, I think I'm going to count by twos. So we're going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I know I need 21, but I'm just going to go just past it to plot my 21. This has to be even, so if you're going to count by twos, make sure you count by twos the entire time. You can't just jump around. All right, for my Y values, let's see what my low and high values are. So my lowest looks like it is 5.3 and my highest is 30. So I need to be able to include from 5 to 30 here. I have 10 spaces. I think I'm going to count by threes. So 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Okay, I've got my axes labeled. I have my titles on each one. I think I am ready to start plotting. So we are going to plot each one of these ordered pairs as carefully as we can. They don't have to be completely perfect, but we need to be able to get a solid summary of our data. So I'm going to plot each one. So I've got 21 and 30, so just past my 20 and up to 30. I'm going to check them off as I go. 1.4 and 7. 5 and 9. 15 and 27. 1.6, and 5.3. 7 and 12. You can probably start to see the pattern already. 16 and 28. 2 and 8. And finally, 10 and 26. Okay, I've got all my data points plotted. I can kind of see a positive trend here. We've got a pretty decent gap in data right here, meaning we don't really have a ton of information about any of these sports balls that weigh between 8 and 14 ounces. But I think we've got a pretty decent trend line here. So we're going to analyze this, kind of take a look at it, see what you think, and then we've got a couple of follow-up questions. So let's take a look at these questions and see if we can answer them together. Make sure you can see all of that. I think you can. All right, first question. Is there a linear relationship shown between weight and circumference of each ball based on the data? I would say yes, right? We agreed that there is definitely a linear trend here. And it says, if so, draw a trend line. So I'm just going to use a straight edge. This doesn't have to be perfect, but we're just going to draw ourselves a little trend line. We want to get about half the data above and half the data below our trend line. Okay, so we did this and we're saying, yep, we think that this is linear. And I would say it's got a positive trend. And I know it's positive rather than negative because it's going up as we read from left to right. All right, so that would have stopped everything that we learned up till today. But now we're going to take it a little bit further and we're going to look at our trend line a little bit more in depth. So it's asking, what is the rate of change or the slope shown by the data? So we're going to take a look at our graph and we're going to look at the rate of change. So we know how to count slope. It's actually kind of, look at this is kind of nice. From here to here, we're going up. Remember, we counted by threes. So up 3 and over 2. So up 3 and over 2 means that my slope, which is change in y divided by the change in x, would be positive 3, right? We went up 3 and right 2. So my slope is 3 over 2. Next, it asks us to identify the y-intercept in the data. So y-intercept is where it's crossing the y-axis. Here's the y-axis. We're crossing just above the 3. So let's say maybe at 4. I think that would be fair, right? So right here, we're saying it's crossing at about 4. So the point 0, 4 is where we're crossing the y-axis with our trend line. So we would say B is 4. The final thing they ask you to do is write the equation of a trend line that summarizes the data. Now, when you write an equation, the easiest form for us to use at this point is y equals mx plus b. We know the m value. We just found it, right? It's this, our up 3 over 2. So we know that this is 3 over 2. And we know that our b value is 4 because that's where it's crossing the y-axis. So my equation for my trend line would be y equals 3 over 2x plus 4. We just wrote the equation of a trend line. So the next thing you guys are going to do is practice this on your own. So we've got a totally different one to graph. And my hope is that you guys will be able to plot these points and answer some follow-up questions. So if you're comfortable, you can hit pause at this point. You can do this on your own and hit play when you're ready for the answers. If you're not comfortable, then you can just stay on and follow along. So it says the table shows the number of absences and the final grade for each student in a sample. Write the ordered pairs, we already did that, and graph them on the coordinate plane. Okay, this one, the axes are already drawn in for us, which is kind of helpful. So what we're going to do first is just plot each one of these data points. So number of absences and final grades. So somebody with 0 absences earned a 95. 3 absences earned somebody an 88. 2 absences, the person got a 90. 5 absences, 83. 7 absences, 79. 9 absences earned a 70. I'm starting to see a trend. 4 absences got an 85. 1 absence, 94. 10 absences and a 65. And finally, 8 absences earned a 75. Okay, there's my data. And let's look at the follow-up questions. Is there a linear relationship shown between absences and final grades based on the data? I would say yes. This looks like a pretty strong linear relationship. So if so, draw a trend line. Again, we want about half of it above and half of it below, the best you can. I don't see any outliers. We do have a little bit of a gap in data, but not much. We just don't really have a lot of information about 6 absences. This has a negative slope. So this is linear with a negative slope. Okay, now it asks us for the rate of change shown by the data. Be careful here because each one of these blocks is 10 units. This way is 1 unit. So I'm gonna find a rate of change and I'm gonna go from here to here. So I'm gonna go down 10 units and over 1, 2, 3. So this is down 10 and this is right 3. So that means my slope would be negative 10 over 3. Y-intercept of my data. What happens when the x value is 0? Well, lucky for us, we've got a point. It's at 95. So 0, 95 is where it crosses the y-axis. So I'm going to say that b equals 95. We have everything we need to write an equation. So our linear equation that would summarize the data is going to be in y equals mx plus b form. We know the m value is negative 10/3, and we know the b value is 95. So I'm just going to plug them in. Y equals negative 10/3 x plus 95. That's my equation.